It's an odd thing to consider, but when the age of dinosaurs ended, it wasn't really the end of the story. In a way, it was just the beginning of a new chapter, one where the supporting cast stepped into the spotlight. And among these new players were the terror birds. These feathered nightmares emerged from the ashes of extinction, proving that nature abhors a vacuum, especially when it comes to apex predators. They filled the ecological void left by the dinosaurs, becoming the new terrors of the Earth. Roughly 53 million years ago, in the early Eocene, the world was a very different place. It was a hothouse, with lush forests stretching from pole to pole, filled with a diverse range of life forms that emerged after the dinosaurs disappeared. It was in this steamy prehistoric paradise that the first terror bird, Paleopsilopterus, made its debut. This Brazilian bird stood at a modest height of about 3 feet. At first glance, it might not have seemed particularly terrifying. In fact, it was about the same size as a modern-day stork. Hardly the stuff of nightmares, you might think. But appearances can be deceiving. Paleopsilopterus had something its contemporaries lacked: potential. What set Paleopsilopterus apart was its agility and speed, traits that would become hallmarks of its descendants. While it may not have been the apex predator of its time, dwarfed by monstrous crocodilians and giant snakes, it was a harbinger of things to come. The Oligocene epoch, spanning from about 34 to 23 million years ago, marked a turning point in the terror bird saga. It was during this time that the family truly began to live up to its name, with the emergence of giants that would have given pause to even the bravest of prey, Paraphysornis. This Brazilian bird was an absolute behemoth that stood 4.5 feet tall and weighed a whopping 400 pounds. To put that into perspective, Paraphysornis outweighed the largest living bird today, the ostrich. This was no lightweight contender. Paraphysornis was built like a feathered tank, with robust bones that spoke of raw power. Paleontologists believe that Paraphysornis hunted using a combination of kicks, slashes, and powerful jabs with its sharp beak. It's a hunting style that might remind one of a prehistoric version of mixed martial arts, with Paraphysornis as the undefeated heavyweight champion of its time. But Paraphysornis wasn't just a mindless brute. Like many of its terror bird kin, it likely possessed a level of intelligence that set it apart from other contemporary predators. Studies of terror bird brain cases suggest that they had well-developed visual and auditory centers, indicating keen senses that would have made them formidable hunters. As impressive as Paraphysornis was, it was merely setting the stage for what was to come. As we step into the Miocene and Pliocene epochs, spanning from about 23 to 2.5 million years ago, we encounter the true giants of the terror bird family. These were creatures that pushed the boundaries of what it meant to be a bird, reaching sizes that rivaled the predatory dinosaurs of old. 3 names stand out in this pantheon of avian terrors: Titanis, Kelenken, and Brawn. Each of these genera represents the pinnacle of the terror bird lineage, and each had its own claim to fame. Titanis, the youngest and smallest of the trio, was also the most adventurous. While most terror birds were content to dominate South America, Titanis had grander ambitions. It crossed the newly formed land bridge connecting North and South America during the Great American Interchange, becoming the only large South American predator to successfully establish itself in North America. Unlike most of its relatives, this bird lived in what is now the United States, including the states of Texas, Florida, and California. Standing 6.6 feet tall, Titanis would have been an imposing sight for the mammals of North America. Imagine the shock of a Pleistocene horse or ground sloth, accustomed to watching out for saber-toothed cats and dire wolves, suddenly confronted by this alien predator, half bird, half nightmare. But as impressive as Titanis was, it was dwarfed by its cousins back in South America. Its weight likely made it slower than its more nimble cousins, but what it lacked in speed, it made up for in raw power. I imagine Brontosaurus as the tank of the terror bird world, capable of steamrolling over any prey unfortunate enough to cross its path, while the giant terror birds like Kelenken and Brontosaurus might have relied on their size and power to dominate their environments. Many of their relatives took a different approach. Speed, it seems, was just as important as size in the terror bird playbook. Studies of terror bird leg bones have revealed a structure remarkably similar to that of modern-day ostriches, with short thigh bones paired with elongated lower leg and foot bones. This adaptation is a clear indicator of high-speed running ability. Paleontologists estimate that many terror birds, including some of the larger species like Titanis, could have reached speeds exceeding 30 cm/s. That's faster than Usain Bolt, while standing twice as tall and weighing several times as much. But speed wasn't just about chasing down prey. For many terror birds, especially the smaller and medium-sized species, it was also a crucial defensive adaptation. In a world filled with other large predators, including giant carnivorous mammals and enormous crocodilians, the ability to make a quick getaway could mean the difference between life and death. This combination of speed and size made terror birds versatile predators capable of adapting to a variety of hunting strategies. To a casual observer, it might appear to be resting or even dozing, but in reality, every fiber of its being is alert, its incredibly sensitive ears picking up the faintest rustle of leaves or the softest patter of tiny feet. In an instant, it can pinpoint the location of its unsuspecting prey and launch into action. This combination of visual and auditory prowess made terror birds the complete predatory package. It's no wonder these birds were able to dominate their ecosystems for millions of years. But even the mightiest rulers faced their downfall, and the reign of the terror birds was no exception. For millions of years, these avian predators had ruled supreme in South America, developing into a diverse array of species that filled various ecological niches. But somewhere along the line, their luck ran out. Traditionally, the extinction of the terror birds was linked to the Great American Interchange, a major paleobiogeographic event that occurred about 2.7 million years ago. This event saw the formation of the Isthmus of Panama, creating a land bridge between North and South America. As a result, animals from both continents were able to migrate across this newly formed connection, leading to a significant reshuffling of fauna. The conventional wisdom held that the influx of new predators from North America, including cats, dogs, and bears, outcompeted the terror birds, leading to their eventual extinction. It was a neat and tidy explanation that seemed to make perfect sense. However, as is often the case in science, the truth has turned out to be more complex and nuanced. Recent studies have cast doubt on this simple competition-based extinction model, revealing a more intricate tapestry of factors. The terror birds. The name alone evokes a sense of primeval dread. But what truly fascinates me is how close these feathered giants came to crossing paths with humanity. For years, I understood that they vanished about 1 million years ago. But new fossil discoveries have dramatically changed that timeline, pushing their extinction much closer to our own emergence. Some smaller species persisted until a mere 96,000 years ago, a blink of an eye, geologically speaking. And then there's the tantalizing find, fossils of an unidentified terror bird from just 18,000 years ago. If that's confirmed, these birds survived almost until humans arrived in South America, roughly 15,000 years ago. What would it have been like to encounter such a creature? Could the legends of giant birds in South American folklore hold a grain of truth? While a direct encounter seems unlikely, I can't dismiss the possibility that stories of these creatures were passed down through generations. After all, other megafauna, like woolly mammoths, left lasting marks on human culture. The terror bird's story is not a simple tale of being outcompeted. When I examined the fossil record, I noticed that most terror birds, along with many of their South American competitors, disappeared long before placental predators arrived in significant numbers. This timing mismatch suggests something else was at play. The success of Titanis in North America also argues against the idea that terror birds couldn't compete with placental mammals. Titanis expanded its range northward and coexisted with large canids and felines for millions of years. Some terror birds were clearly capable of holding their own. So, what did doom them? It likely involves a complex interplay of factors, with climate change playing a significant role. From the Oligocene to the Pliocene, Earth's climate was on a long-term cooling trend, culminating in a series of ice ages. This global cooling would have profoundly impacted the ecosystems that terror birds called home. As temperatures dropped and habitats changed, the lush forests that many terror bird species relied on would have given way to more open grasslands. While some terror birds may have adapted, others would have struggled. The larger, more specialized species, in particular, might have found it difficult to find enough prey to sustain their massive bodies in these changing environments. The influx of new competitors from North America, while perhaps not the primary cause of their extinction, would have added additional prey to already stressed populations. This formidable beast was larger than its modern-day counterparts, with adults weighing up to 20 to 25% more than the average present-day Siberian tiger. Larger males typically weighed upwards of 400 kilograms, making them close contenders for the title of largest felines ever. Judging from the enormous size of these giants, it's easy to assume that tigers have always been this large. However, a look through history tells us something completely different. Tigers haven't always been this big. Early tigers, existing long before the Nyandong tigers, were notably smaller in terms of body size and weight. This smaller stature could be attributed to the available prey and the ecological niches they occupied, A smaller body size offered energy conservation and agility advantages across various terrains. Early big cats related to tigers, such as Panthera paleocinensis, likely averaged around 70 to 120 kilos in weight. Following them was the Trinil tiger, popularly believed to be the ancestor of all known Indonesian subspecies. I've often wondered about the lives of apex predators. Imagine ruling the wild, sitting right at the top of the food chain. It certainly has its perks. But here's the thing I've learned. Even the most fearsome hunters aren't always the biggest beasts around. Because when it comes to the predator game, size isn't everything. Although, when it comes to the matter of size, it appears that they were evenly matched, as the largest species of Smilodon, the Smilodon populator, weighed between 220 and 436 kilos and stood 120 centimeter tall, which is not that far off from that of the Nagandong tiger. A less formidable rival for the Nagandong tiger would have been the giant short-faced hyena, which stood about 90 to 100 centimeters at the shoulder and averaged 110 kilos in weight. However, a group of animals that the Nagandong would not have dared to infiltrate were the dire wolves. Although they had smaller jaws and weighed way less than the Nagandong tiger, they had a unique edge over it. And that is because they hunted in packs of more than 4 individuals. In contrast, as a solitary hunter, it would have been quite difficult for the Nagandong tiger to match that intensity when attacking prey. This factor placed it at a disadvantage in the competition for apex predator status. However, that was not the only thing the Nagandong tiger had to worry about when defending the apex predator title, because around this time, the early humans were notably prevalent in Southeast Asia, as over 80 individual remains have been found in that region today. So it's likely that they would have crossed paths with the Nagandong tiger. While climate change undoubtedly played a role, scientists propose that the presence of early humans in Southeast Asia might have been among the reasons why the tigers went extinct. They likely caused increased competition for resources or potential conflicts that impacted the Nagandong tiger population. Other factors may have also contributed to their demise, but with limited fossil records, we are left with many unanswered questions. There was once a feline that prowled our planet, not too long ago. It was the undisputed monarch of the Ice Age, the Smilodon. Instantly recognizable, thanks to its iconic saber teeth and fierce appearance, it even starred in films like Ice Age. But the story didn't start that way. Imagine yourself in Brazil, about 160 years ago. Here, our tale begins with a discovery that would perplex the scientific community. When the first Smilodon remains were unearthed, paleontologists didn't immediately recognize them as belonging to a cat. Based on some isolated cheek teeth that bore an uncanny resemblance to those of modern hyenas, they dubbed this new find hyena neoga. Within a couple of years, though, the tides of discovery brought forth a tsunami of new fossils. Suddenly, scientists weren't just looking at a few teeth, but a veritable jigsaw puzzle of prehistoric proportions. Foot bones, skull fragments, and those iconic canines, which seemed almost comically oversized, painted a very different picture. Fatalis and S. populator. Now, if you found yourself face to face with any of these species, You probably wouldn't be too concerned with which one was about to turn you into lunch, but they did have their differences. First up, we have S. gracilis, the elder statesman of the group. This appeared in North America about 2.5 million years ago, descending from an even older genus called Meganterion. Next came S. fatalis, strutting onto the scene roughly 1 million years later. Last, but certainly not least, S. populator made its grand entrance about 600,000 years after fatalis, fashionably late to the Ice Age party. S. gracilis, while no slouch in the size department, was the runt of the litter, tipping the scales at about the same weight as a modern jaguar. S. fatalis, living up to its name, was a step up in the terror department, matching an African lion in size, but packing on extra muscle like a feline bodybuilder. We're talking about 280 kilos, or 620 pounds, of prehistoric fury. That's on par with the largest tigers roaming the earth today. But S. populator dominated them all. This behemoth pushed the boundaries of felid physiology, with the largest known specimens estimated to have weighed in at a jaw-dropping 470 kilos, or 1,040 pounds. To put that in perspective, that's about the same as a medium-sized polar bear. Interestingly, unlike many modern big cats, Smilodons didn't seem to be too hung up on gender norms. Studies suggest that there wasn't a significant size difference between males and females, a trait scientists call low sexual dimorphism. In practical terms, this means that regardless of whether you were facing a male Smilodon or a female Smilodon, you were in for equally big trouble. Now, being big is impressive, but Smilodon wasn't just large. It was built like a prehistoric tank. The Smilodon's heel bone was a marvel of natural engineering, robust and elongated. In fact, some paleontologists speculate that these Ice Age acrobats could have outjumped modern lions, which have been observed clearing heights of 15 feet, or 4.5 meters. Imagine a cat the size of a bear, capable of leaping over a one-story building. But the Smilodon's athletic prowess didn't stop at its fancy footwork. If modern big cats have arms that could crush you, Smilodon's forelimbs took it to the next level. We're talking about limbs that were approximately 20% thicker than what you'd expect for a cat of its size, giving it incredible strength, surpassing even that of the larger American lion. And at the end of those muscular arms, Smilodon was further armed with fully retractable claws, razor-sharp and curved like prehistoric scimitars. They were proportionally enormous, even for a cat of Smilodon size. We're talking about claws twice the size of a Siberian tiger. Those impossibly long canines. They've captured imaginations for generations. Saber teeth aren't unique to the Smilodon, but it perfected the design. It took the concept to an entirely new level. I've always been struck by the sheer audacity of their length. We're talking about canines so long they protruded well beyond the lower jaw, a feature uncommon even among other saber-toothed cats. To put it in perspective, Smilodon's canines could grow up to 8 inches long. That's longer than many modern kitchen knives. They were precision instruments of prehistoric destruction, shaped like deadly daggers with sharp points and smooth, narrow sides. These teeth were designed to pierce deep into flesh with devastating efficiency. But here's where things get really interesting. You'd expect a predator with teeth like that to have a powerful bite to match. Surprisingly, studies have shown that Smilodon's bite was relatively weak. Only about 1,000 newtons, 4 times weaker than a modern lion's. So how did it kill? That's been a subject of much debate among paleontologists. One popular theory suggests Smilodon was the original ambush predator. I picture it hidden in dense vegetation, waiting for the perfect moment. Then, with a powerful leap, it pounces on its unsuspecting prey. Using those muscular forelimbs and grappling hook claws, it pins down its victim. With precision, it sinks its saber teeth into the prey's soft underbelly, causing massive internal damage and blood loss. But not everyone buys this gut-stabbing hypothesis. Many researchers favor a different, but equally grim, scenario. They propose that Smilodon used its powerful build to quickly overpower its prey, then delivered a precise lethal bite to the throat. This would have caused severe blood loss and suffocation, a quick, if not particularly pleasant end for its unfortunate victims. Adding fuel to this theory is the discovery that Smilodon could open its jaw to an incredible 120 degrees. That's almost twice as wide as a human can manage. With a gape like that, pretty much every neck in the Ice Age would have been fair game. But Smilodon wasn't just brawn and teeth. Brain scans of Smilodon skulls suggest these prehistoric predators had excellent coordination, sharp hearing, and top-notch vision. Their eye socket shape hints at binocular vision, giving them the depth perception needed to judge distances accurately, crucial for a predator that relied on ambush tactics. And, if all that wasn't enough, they were fast too. Many Smilodon fossils show trauma to their sternums, the kind of injury you'd expect from high-speed collisions. This suggests that not only were they quick on their feet, but they were also willing to risk life and limb, or at least a bruised chest, in pursuit of their next meal. Smilodon's unique traits, along with its powerful weaponry, made it a versatile hunter capable of taking down a wide variety of megafaunal prey. The specific animals it targeted varied based on the region it called home. Some researchers point out that Smilodon remains found outside of predator traps tend to be more isolated, suggesting a more solitary lifestyle, more in line with many modern big cats. Regardless of whether Smilodon was a team player or a loner, one thing's for: it was at the top of the food chain. But that doesn't mean it didn't have competition. The Ice Age was a time of giants, and Smilodon wasn't the only predator with an appetite for mammoth-sized meals. Two of Smilodon's biggest rivals were the American lion and the dire wolf. Now, while real dire wolves were impressive, they weren't quite as monstrous as their fictional counterparts. But they were formidable predators in their own right. Isotope analysis shows that they had a diet very similar to Smilodon's, meaning these predators were often competing for the same prey. So, how did Smilodon stack up against its competitors? Well, when it came to the American lion, it was probably a bit of a standoff. The American lion had size on its side, being one of the largest cats to ever exist. But Smilodon had those impressive canines, which likely served as a pretty effective deterrent. Most likely, these two apex predators tried to avoid each other when possible. But when conflicts did occur, it could have gone either way. The dire wolf, on the other hand, seems to have often come out second best in confrontations with Smilodon. Evidence from La Brea suggests that dire wolves would frequently abandon their kills when a Smilon showed up. It's not hard to imagine why. Given those sabers being on full display, most predators probably decided that discretion was the better part of valor. But lions and wolves weren't the only competition Smilodon had to worry about. The Ice Age was also the time of the short-faced bear, a beast that could make even Smilodon look small by comparison. Some of these bears reached truly dinosaurian proportions in weight. However, these ursine giants were more omnivorous than Smilodon, which likely reduced direct competition. Plus, bears tend to be solitary creatures. So, if a group of Smilodons encountered one, the bear would likely have decided that this particular picnic basket wasn't worth the trouble. Now, we've talked a lot about Smilodon's impressive hunting adaptations. But there's one question we haven't addressed yet. How on earth did it eat with those ridiculous teeth? After all, those saber-like fangs seem like they would have been quite the obstacle during feeding. Well, Smilodon had a solution for that too. Unlike most predators that can chomp down from the front, Smilodon was equipped with specialized slicing teeth called carnassials. These teeth, situated on the sides of the mouth, worked like biological scissors, shearing through meat with ease. We're talking about a world where you might encounter short-faced bears, proboscideans, ground sloths the size of cars, armored glyptodons, the rhino-like toxodon, camels, deer, horses, bison, and even terror birds. It was like a real-life version of the ice levels in every video game, but with 100% more lethal prehistoric cats. But there was one more species that Smilodon encountered in its twilight years, one that would change the face of the planet forever: humans. It's believed that our ancestors might have first crossed paths with Smilodon around 25,000 years ago. Now, imagine being one of those early humans, armed with nothing but primitive tools, coming face to face with a saber-toothed cat. The relationship between humans and Smilodon was likely a tense one. After all, we were competing for many of the same food sources. And unfortunately for our ancestors, by the time humans arrived on the scene, only the largest populator and Spatulus remained. Talk about bad timing. Given that Meganterion, the possible predecessor of Smilodon, was known to occasionally prey on Homo erectus, it's not a stretch to imagine that Smilodon might have considered early humans as potential prey, too. I've often wondered about the moment our ancestors might have first encountered a Smilodon. There's no direct evidence of human Smilodon confrontations, but it's likely our technology and group tactics sometimes gave us the upper hand. If you've ever stared into the eyes of a large crocodile, you understand the primal fear that comes from seeing a predator perfectly designed for aquatic ambush. Now, imagine that same sinister profile scaled up to dwarf any modern crocodilian, mounted on a body that could rear up 20 feet into the air. The skull alone weighed as much as a small car, yet it cut through water with the efficiency of a torpedo. Those jaws housed over 60 interlocking teeth, each one a curved, needle-sharp instrument of death designed for one purpose: gripping slippery, struggling prey underwater. Unlike the bone-crushing teeth of T-Rex, built for delivering massive bite forces to terrestrial victims, Spinosaurus's teeth were fishing spears made of enamel. Once those jaws clamped down on a 15-foot sawfish or massive lungfish, escape became physically impossible. But the skull was just the beginning of this creature's aquatic arsenal. Where other theropods developed powerful legs for running down prey across land, Spinosaurus rewired its body for a different kill zone. Its toes were webbed, its legs positioned differently, its entire lower body redesigned for propulsion through water rather than speed across terrain. For anything living in those rivers, the nightmare was the same. The faint ripple at the surface, the sudden silence, and then the 7-ton shadow sliding in after you. When Spinosaurus needed to move through shallow water, it acted like the keel of a boat, providing stability and control where other large predators couldn't navigate. Even at 7 tons, it was streamlined enough to move with deadly grace. Great white sharks inspire fear because they embody millions of years of aquatic mastery. But Spinosaurus had even longer to sharpen that deadly craft, with added intelligence, versatility, and sheer size that dwarfs any marine predator alive today. It transformed every waterway into its personal killing field. Those paddle feet weren't just for show either. They propelled Spinosaurus through the water with surprising speed, allowing it to pursue prey through underwater mazes where other large predators would become trapped. Unlike purely aquatic predators that relied on ambush, or terrestrial ones limited to shoreline attacks, this nightmare could adapt its hunting strategy in real time. Miss your target underwater? Simply rise to the surface and snatch prey from above with those powerful arms. Prey takes refuge in shallow water. Those webbed feet provided perfect stability for wading attacks that no other large theropod could attempt. The hunting scenarios become even more terrifying when you consider Spinosaurus's intelligence. Crocodiles are clever hunters, but they're still reptiles operating on instinct. It was a perpetual killing machine, turning every waterway into a crime scene where death could strike from any angle. 100 million years ago, the region we now call southeastern Morocco told a very different story. It wasn't endless desert, but a lush river system snaking across North Africa. The waterways supported ecosystems so abundant and diverse they defy imagination. Massive channels, swamps, and floodplains transformed the landscape into one of the most dangerous habitats ever. Every bend in the river could conceal a predator beyond comprehension. This was the Kelenken Beds Formation, a prehistoric paradise that had become, quite literally, hell on earth for anything trying to survive in its waters. Picture a world where rivers ran deeper and wider than the Amazon, where tropical forests stretched beyond every horizon, and where the very air hummed with the calls of creatures that would dwarf modern elephants. The climate was so warm that palm trees grew at what we now consider Arctic latitudes, and so humid that massive thunderstorms rolled across the landscape with mechanical regularity, feeding the endless network of rivers and swamps. And in this steaming, river-choked ecosystem, Spinosaurus was far from alone. The Kelenken Formation reveals that this aquatic terror shared its territory with a deadly mix of predators, prey, and rivals. Yet, lurking in North America's ancient past was a predator so extraordinary it could make today's largest wolves look like lapdogs. Today's grey wolf may hold the crown as the largest living canid, reaching weights at 65 kilomon or 143 lbn. But rewind to the Eocene epoch 20 to 5 million years ago, and the game changes. A new apex predator emerges, Epicon, a colossal predator so fearsome it could rival a lioness in size and had jaws powerful enough to outmatch a grizzly bear. In simpler terms, this was a dog that could eat a lion. Its name says it all, Epicyon, meaning more than a dog, because calling it just a dog doesn't do it justice. The story of Epicyon's discovery represents one of paleontology's most intriguing progressions, from misidentification to revelation. Over 160 years ago, in the fossil-rich sediments of Nebraska, scientists unearthed the first fragments of what would later be recognized as the largest canid species ever to walk the Earth. The initial discovery consisted of a fragmented lower jaw. While obviously from a large carnivore, it provided only hints of the creature's true nature. The jaw's wolf-like characteristics led early paleontologists to classify it as a subgenus of Canis, the genus that includes modern wolves, coyotes, and jackals. This classification seemed logical at the time, given the limited fossil evidence. That combination of enlarged premolars and strategically placed canine teeth, closer to the jaw joint than in modern canids, created a supremely efficient biting machine. New analysis suggests Epicyon's bite force may have exceeded 16,000 newtons. To put that in perspective, that's comparable to a large American alligator. The closer placement of the canines to the jaw joint created a more efficient lever system, concentrating enormous force at the tooth tips. The result was a bite that could pierce thick hide, flesh, and even bone with ease. And it wasn't just theory. Microscopic analysis of wear patterns on preserved teeth provides direct evidence of how Epicyon used its bite. The patterns are consistent with both flesh slicing and bone crushing, suggesting a predator that could efficiently process every part of its prey. Fossil deposits tell us that Epicyon was an opportunistic predator, capable of taking down a wide range of prey. Their remains have been found alongside ancient camels, pronghorns, horses, and peccaries. Most impressively, they seem to have hunted prehistoric rhinoceros species like Teleoceras, which could reach lengths of 4 meters and weigh nearly 2 tons. Recent studies suggest Epicyon may have used different hunting strategies depending on the prey. For smaller animals, they likely hunted alone or in pairs, using their speed and power to overwhelm their victims. But there's increasing evidence that they also engaged in pack hunting, especially when targeting larger prey. This idea of social hunting is supported by several lines of evidence. Nearly all well-studied modern canids exhibit some degree of social behavior, and most hunt cooperatively. The fossil record also lends weight to this theory. Epicyon fossils are... I've always been fascinated by creatures that defy expectations, and Epicyon definitely fits that bill. It wasn't the tallest, the fastest, or the most fearsome predator, but it thrived for millions of years in North America. Its success wasn't about brute strength, but about a unique set of adaptations that allowed it to survive in a world of constant change. Epicyon. The name itself sounds like something out of a myth, but its existence was very real. What's particularly fascinating to me is how abundant their remains are in North American deposits. It's a pattern you usually see with social predators, which suggests that Epicyon wasn't a solitary hunter. These animals seem to have maintained stable populations across their range, something more characteristic of pack-hunting species. Looking at their physical construction, I see even more clues about their hunting behavior. Epicyon had a more robust skeletal structure, heavier bones than most other canids, both modern and extinct. While primarily carnivorous, the structure of their teeth suggests they could also process tough plant material when necessary. This dietary flexibility, combined with their bone-crushing abilities, would have allowed them to survive in a wide range of environments and through various seasonal changes. The ultimate disappearance of Epicyon from the fossil record has long intrigued paleontologists. Early theories suggested that competition from newly arriving big cats led to their extinction. However, this hypothesis has largely been discounted, as many of the large cats that would have competed with Epicyon, such as the famous Smilodon, didn't appear in North America until millions of years after Epicyon's disappearance. Current evidence points to climate change as the primary driver of Epicyon's extinction. The late Miocene saw significant global cooling and increased aridity, leading to fundamental changes in North American ecosystems. Recent paleobotanical studies indicate a shift from mixed woodland savanna environments to more open grasslands. This transformation would have affected not only the types of prey available, but also hunting strategies. Epicyon's specialized adaptations, its heavy build, bone-crushing teeth, and relatively short legs may have become disadvantageous as prey species became faster and more adapted to open environments. Unlike their more generalized relatives, which gave rise to modern wolves and other canids, Epicyon's extreme specializations may have limited its ability to cope with these changing conditions. I'll never forget the moment I first saw the pictures. A jumbled mess of armor plates, bones, and teeth. It was a paleontological puzzle that would everything we thought we knew about dinosaur defenses. What emerged from that chaos was Ankylosaurus magnaventris, a creature so unique it demanded its own family. The name itself is a clue. Ankylosaurus, meaning fuse lizard, hints at its incredibly fortified skeleton. And magnaventris, or great belly, speaks to its broad midsection. The discovery wasn't just another find. It was a portal into the intricate design of a truly formidable being. It all started in 1906. Barnum Brown, a paleontologist from the American Museum of Natural History, was leading an expedition through Montana's Hell Creek Formation. He unearthed a collection of fossils that, at first, baffled him. These weren't the typical slender bones of theropods or the broad frills of ceratopsians. Instead, he found fragments of bony plates, oddly shaped teeth, and vertebrae that suggested a heavily armored animal unlike any he'd seen before. Initially, Brown was cautious. He speculated that these bones might belong to a completely new type of armored dinosaur. Over time, further excavations in Canada and the western United States revealed more specimens. Each find shed more light on the creature's incredible physical characteristics. Piecing together its skeletal framework was like working on a prehistoric jigsaw puzzle, each discovery adding another layer of complexity to the story. What truly made Ankylosaurus magnaventris stand out was its robust anatomy and its ecological implications. Fossils were found alongside plant remains, painting a picture of the lush environments it once roamed. And as paleontological techniques advanced, CT scanning, isotope analysis, we've been able to reconstruct its appearance and understand its lifestyle in remarkable detail. From its armoured plates to the club at the end of its tail, Ankylosaurus epitomized nature's ingenuity. But the groundbreaking aspect of this discovery wasn't just a new species. It became the cornerstone of an entirely new group of dinosaurs, the Ankylosauria. These animals, part of the larger clade Ornithischia, were defined by their extensive armor plating and herbivorous diets. Within this group, Ankylosaurus belonged to the Ankylosauridae family, distinguished by their massive triangular skulls, stocky builds, and elaborate defenses. Among all its relatives, Ankylosaurus held a special distinction. It was the largest of its kind ever discovered. Adults reached lengths of 5.4 to 10 meters, or 17 to 33 feet, standing about 1.7 meters at the hip. We've known about its bony plates, or osteoderms, for decades, but recent microscopic analysis has revealed an intricate network of blood vessels running through them. This suggests that the armor served multiple purposes, not just protection, but also possibly helping to regulate body temperature, much like some modern reptiles use their scales for thermoregulation. The exact number of these osteoderms is still debated, with estimates ranging from 30 to well over 100. What's particularly intriguing is their unique construction. Unlike other armored dinosaurs with solid, thick plates, the Ankylosaurus possessed osteoderms with hollow undersides. This seemingly counterintuitive design was actually a remarkable feat of natural engineering. The hollow structure created a dome-like formation that distributed impact forces more effectively than solid plates, similar to how modern motorcycle helmets use their curved design to protect riders. I've always been fascinated by the sheer force of nature, especially when it comes to defense. The Ankylosaurus, a creature armored head to toe, faced predators like T-Rex, whose hunting strategy relied on bone-crushing bites. But beneath those armored plates lay a network of collagen fibers, far surpassing anything we use in modern protective materials. It's a marvel of natural engineering. Modern engineering analysis has given us more insights into this remarkable defense system. These fibers, significantly thicker than those in modern armored animals like crocodiles and armadillos, created a natural composite, almost like modern fiber-reinforced plastics. Biomechanical studies have shown that this combination of hard plates and flexible fibers could absorb and dissipate energy from impacts in ways that purely rigid armor simply couldn't match. In fact, reconstructions of Ankylosaurus armor, when subjected to simulated impact tests, proved capable of withstanding forces that would have seriously injured or even killed most other dinosaurs. But perhaps the most fascinating aspect of its defenses was its tail club. It wasn't just a simple bony growth, it was a precisely engineered weapon system, one of nature's most effective deterrents against predation. Recent CT scans of tail club fossils have revealed an intricate internal structure, optimized for both strength and swing speed. The club itself was composed of two large osteoderms at its core, complemented by smaller ones at the tip and along the midline, all supported by a framework of highly modified vertebrae that was specifically adapted to handle the stresses of high-speed impacts. The mements are truly staggering. As specimens show, the club could reach 57 centimeters or 22.5 inches in width and weighed approximately 23 kilos or 50 pounds. But these numbers only tell part of the story. The real marvel was in the biomechanics. Advanced computer modeling has shown that large individuals could generate impact forces exceeding 20,000 newtons, and even more remarkably, could achieve swing impulses of up to 4,800 newtons per second. To put this in perspective, while a professional baseball player generates about 13 newtons per second in their swing, the Ankylosaurus's tail strike was 370 times more powerful. Recent studies using finite element analysis have even suggested that the impact force could have been focused on an area as small as a few square centimeters, multiplying its bone-crushing potential. The behavior and lifestyle of Ankylosaurus were as unique as its anatomy. While much of its life remains a mystery, fossil evidence offers glimpses into its daily routines and survival strategies. Juvenile Ankylosaurus specimens, for example, lacked the fully developed armor and tail clubs seen in adults. This vulnerability likely necessitated group behavior during the early stages of life. Trackway fossils suggest juveniles may have formed protective herds, with larger individuals shielding the more vulnerable young in the center, a defensive strategy reminiscent of modern musk oxen. As they matured, Ankylosaurus individuals underwent significant lifestyle changes. Adults appear to have been predominantly solitary, a conclusion supported by the rarity of adult specimens found in groups. The large gut volume would have provided ample space for fermentation and nutrient absorption, ensuring the animal could survive on a diet of relatively low-calorie plants. This adaptation, combined with its sturdy build and slow metabolism, likely made Ankylosaurus an efficient grazer, well suited to its environment. Its sensory capabilities were as finely tuned as its defensive adaptations. Its most remarkable sensory feature was its highly developed sense of smell, which would have been vital for locating food, avoiding predators, and possibly even detecting mates. Fossil evidence reveals that the olfactory bulbs in its brain were unusually large for an herbivorous dinosaur, suggesting its sense of smell was on par with, or even superior to, that of many modern reptiles and mammals. Recent studies of Ankylosaurus skull fossils using advanced imaging techniques have revealed intricate nasal passages. These passages likely played a dual role, enhancing its olfactory capabilities and aiding in thermoregulation. The convoluted structure of these nasal cavities, which created a larger surface area, may have allowed Ankylosaurus to cool or warm incoming air, helping it adapt to the varied climates of the late Cretaceous period. Vision and hearing also likely contributed to Ankylosaurus's survival. While its eyes were relatively small compared to its massive body, their placement on the sides of its skull would have provided a wide field of view, allowing it to detect predators approaching from almost any direction. This peripheral vision, combined with its heightened sense of smell, would have made it difficult for ambushing predators like Tyrannosaurus rex to catch it off guard. Though direct evidence for its auditory capabilities is sparse, the structure of its inner ear suggests that Ankylosaurus was capable of detecting low-frequency sounds, which could have been useful for sensing the movements of large predators or communicating with others of its kind. One particularly intriguing hypothesis is that Ankylosaurus may have used its sensory abilities in conjunction with its defensive adaptations. For instance, its acute sense of smell and hearing could have allowed it to detect a predator's approach early enough to position itself defensively, presenting its armored back and tail club to the threat. These advanced sensory capabilities underscore the Ankylosaurus as a highly specialized organism, perfectly equipped to navigate its dangerous environment. The reign of Ankylosaurus came to an end, along with that of other non-avian dinosaurs, during the KT extinction event approximately 66 million years ago. However, its legacy lives on in our understanding of natural design and defense mechanisms. The Cretaceous period was truly an era of titans. But beyond that, Deinosuchus was unique. Its skull shape was unlike anything we've seen in any other crocodilian, living or extinct. The skull itself was huge, up to 5.6 feet long, about the same size as an adult Spinosaurus skull. Despite its size and strong build, studies show that Deinosuchus actually had a surprisingly modest bite force. A study back in 2002 estimated its bite force at around 18,000 newtons. That's enough to crush bones, but it's not as strong as you might expect for such a massive creature, especially when you compare it to the smaller saltwater crocodile, which can exert a bite force of 16,500 newtons. But when you look closely at Deinosuchus fossils, you see that its skull wasn't just big, it was also highly specialized. Its teeth were arranged in a way that showed it was adapted to a predatory lifestyle. It had conical, sharp front teeth for grabbing prey, and blunt, strong back teeth for crushing bones. This unique set of teeth allowed Deinosuchus to hunt all sorts of prey, from large dinosaurs to turtles with hard shells. It was a versatile and formidable predator. The bite force of Deinosuchus has been a hot topic of debate among us paleontologists, with some studies suggesting vastly different numbers. Some initial research pointed to a bite force of around 18,000 newtons, based on the size and structure of the skull. But then another study came along and proposed that Deinosuchus had an incredibly powerful bite force, exceeding 100,000 newtons. Fossilized tail vertebrae of duck-billed dinosaurs found in Texas bear bite marks consistent with Deinosuchus, clear evidence of its feeding habits. Its size and strength made it a threat to even large theropods. Deinosuchus likely preyed on more than just hadrosaurs. Even large theropods like Paleopsilopterus weren't immune. Certain bite marks on their bones have been attributed to it. I find it fascinating that this apex predator likely influenced the size and distribution of other theropods in its eastern habitat. No other theropod in the area reached its size, further solidifying its role as a top predator. Coprolite analysis, that is, the study of fossilized feces, has revealed direct evidence of Deinosuchus's diet. These coprolites contain fragments of dinosaur bones, fish scales, and turtle shells, providing a snapshot of its varied diet. Dr. Karen Chin, a specialist in coprolite studies, emphasizes the importance of these findings, and I agree. The diverse prey items found in Deinosuchus remains highlight its opportunistic feeding behavior, suggesting it consumed everything from large herbivorous dinosaurs to smaller aquatic creatures. It's thought that Deinosuchus used ambush tactics, leveraging its massive size and crushing bite to inflict fatal injuries. Like modern crocodiles, this giant predator likely employed a death roll maneuver to enhance its hunting efficiency. This technique involves grabbing prey and then rapidly rotating, using its body weight and momentum to incapacitate and dismember it. Reconstructing the hunting methods of Deinosuchus involves analyzing fossil evidence and comparing it with the behavior of modern crocodilians. The robust anatomical features of Deinosuchus, including strong neck muscles and a sturdy body, support this hypothesis, suggesting it was a highly effective predator in its ancient ecosystem. Deinosuchus experienced a slow growth rate, as evidenced by growth rings on its osteoderms, bony plates. These rings indicate that it took around 35 years to reach full size. Despite this long maturation period, juvenile Deinosuchus were still formidable predators, sporting considerable size and powerful bites even at a young age. These individuals were equipped with large, thick osteoderms, providing substantial protection against predators and environmental hazards. These osteoderms not only served as armor, but also supported the animal's massive body, increasing its load-bearing capacity and enabling efficient movement on land despite its size. Deinosuchus was a highly successful predator, as evidenced by its extensive range. Remains have been found throughout the United States and northern Mexico. During its prime, the American continent was divided by the Western Interior Seaway, a shallow sea, and Deinosuchus thrived on both sides of this seaway. It inhabited diverse environments, including estuaries, freshwater lakes, rivers, and possibly even deeper marine waters, though some believe the marine remains could have been displaced post-mortem. The adaptability of Deinosuchus is showcased by its preference for estuaries, coastal bodies of brackish water with river or stream inlets. However, it also thrived in freshwater lakes and rivers and was potentially present in marine environments. Its strong limbs and tail allowed it to navigate both aquatic and terrestrial settings, tolerating varying salinity levels, which further demonstrates its ecological flexibility. If Deinosuchus indeed ventured into deeper waters, it might have encountered other giant predators like Tylosaurus, one of the largest mosasaurs. This interaction could suggest a complex predator-prey dynamic within its ecosystem, influencing the behavior and distribution of various species. Deinosuchus lived alongside a vast array of dinosaurs and other prehistoric creatures. It coexisted with herbivorous dinosaurs like Anodontosaurus, Gryosaurus, Cosmoceratops, Utaceratops, and many others. Bite marks on the bones of hadrosaurs and other dinosaurs provide clear evidence of its predatory behavior. Deinosuchus's presence likely impacted the distribution and behavior of these animals, asserting itself as an apex predator in its habitat. Despite its dominance, Dinosaurs vanished from the fossil record around 73 million years ago. The reasons for its extinction remain unclear. Though climate changes, sea level fluctuations, and competition with emerging predators are potential factors, its extinction marked the end of an era. But the fossil remains of Dinosaurs continue to provide valuable insights into the life and ecosystems of the late Cretaceous period. Speaking of apex predators, it always strikes me how the tiger, lion, and jaguar have always fought for supremacy among big cats, each vying to be the ultimate apex predator. But there's one ancient beast that towers above them all: the American lion. This was no ordinary feline. It was the largest to ever walk the earth. Imagine a creature so massive that some individuals weighed as much as an adult brown bear, easily dwarfing today's biggest lions. The American lion. Just the name conjures up images of immense power. But what I find truly fascinating is how recent discoveries have reshaped our understanding of this prehistoric predator. It wasn't just a subspecies of the modern lion, as once believed. It was something far more unique, something truly colossal. Modern science has revealed that, much like the dire wolf, the American lion wasn't quite what we initially thought. Despite its lion-like features, detailed anatomical studies pointed to crucial differences. A more robust build, proportionally longer limbs, and, notably, the absence of a prominent mane in males. These distinctions led to its reclassification as its own species, Panthera atrox, the cruel panther. DNA analysis suggests it emerged from an isolated population of cave lions, trapped south of the North American ice sheets roughly 340,000 years ago. This separation occurred during a crucial period of the Pleistocene epoch, leading to rapid adaptations to the North American environments. While modern lions are their closest living relatives, the last common ancestor lived somewhere between 500,000 and 1.9 million years ago. The sheer size of the American lion sets it apart. On average, they were about 25% larger than today's African lions. Male American lions typically weighed between 351 kg and 420 kg, already larger than any living big cat. But some specimens discovered in 2012 have been estimated to weigh an astounding 523 kg. That's the weight of 8 adult humans combined. Even the largest recorded Siberian tigers rarely exceed 300 kilos. The American lion's only real competitor for size was the Smilodon populator, which could reach weights of up to 470 kilograms. The 2012 discovery firmly established Panthera atrox as the heavyweight champion of the feline world. Despite its enormous size, the American lion maintained the agility and speed characteristic of big cats. Estimates suggest it could reach speeds of over 30 km/h, faster than any human athlete, and comparable to a charging warthog. Unlike other predators, they seemed to avoid these traps, demonstrating an environmental awareness that truly set them apart. Their range was vast, stretching from Alaska to central Mexico. They shared their territory with mammoths, mastodons, giant ground sloths, and even early humans. I've read studies suggesting they left a lasting impression on those early cultures, perhaps even influencing their art and mythology. Then, about 12,800 years ago, it all ended. The extinction event that claimed so many of North America's large mammals likely sealed their fate. Was it the changing climate, the dwindling prey, or the increasing press from humans. Perhaps it was a combination of all these things that pushed these magnificent predators past their breaking point. But now, let's turn our eyes to the skies, to another prehistoric ruler, one that soared over the land with what sounds like an iron fist and a voracious appetite, the Quetzalcoatlus. Its massive wings must have cast an enormous shadow, sending potential prey into a chaotic frenzy, desperate for a place to hide. The first specimen was discovered in Texas in 1971, almost by chance. The paleontologist who found it immediately knew he'd found something monstrous. He was so mesmerized by its size that he named it after an Aztec serpent god, and then, rather wonderfully, after an aircraft manufacturing company. Quetzalcoatlus northropi, the timeless conqueror of the skies, the first of its kind known to humanity. For years, it was considered the biggest pterosaur, the largest flying animal in history. We know it coexisted with the Tyrannosaurus rex, yet so little is known about its biology. Originally, its wingspan was thought to be wider than an F-22 fighter plane. Now, paleontologists believe it was closer to 33 to 39 feet wide, still larger than an F-16, and it stood roughly the same height as a giraffe. Some researchers estimate it weighed nearly as much as a grizzly bear. While a smaller species, Quetzalcoatlus lawsoni, was later identified, northropi always held the spotlight. Recent discoveries of larger pterosaurs, like Hatzegopteryx from Europe, which had a similar wingspan but greater weight and a larger skull, have challenged its title. Yet, Quetzalcoatlus remains the largest pterosaur to have flown over North America. It also had distinctive features. It lacked feathers and a tail, and instead had coarse hair covering its body, giving it what some describe as a striking, almost demonic look. And, perhaps most surprisingly, it was toothless. When I first encountered Quetzalcoatlus, I was struck by its sheer audacity. Imagine a creature with the wingspan of a small plane soaring through the skies. It had an extraordinary metabolism to support its way of life, showing a resemblance to other pterosaurs. For a long time, scientists assumed it was cold-blooded, like other reptiles. Now, we know Quetzalcoatlus was, in fact, warm-blooded and remarkably active. Many theories have been put forth, describing the enormous reptile leaping into the air by flapping its wings, or even lurching forward on its wingtips, much like a vampire bat. In other scenarios, it may have crouched low before launching itself 8 feet into the air, giving it enough room to spread its wings and take off. Its secret weapon, apparently, was those strong hind legs that supported the massive push required to jump. One study suggested that Quetzalcoatlus was a truly remarkable flyer, engaging in brief powered flights before gliding. It might have reached a top speed of 80 km/h, which it could sustain for perhaps 7 to 10 days, giving it an extraordinary range. Despite being relatively small in relation to its overall bulk, Quetzalcoatlus's torso was extremely dense and brimming with massive muscles. It may have been able to take off with a single leap and maintain its altitude with just a few flaps. After that initial launch, they could probably fly non-stop for thousands of kilometers, simply flapping infrequently to maintain altitude and guide their course. Its short wings were made of tightly packed muscle fibers that end flexibility and strength, allowing for very precise adjustments once airborne. The extraordinary flight techniques of Quetzalcoatlus even led to a rather interesting experiment. A Johnson Wax-sponsored mission constructed a model flying machine to test flight simulations. The model, the size of Quetzalcoatlus lawsoni, used a basic computer as an autopilot and successfully demonstrated the effectiveness of these flight techniques by soaring and flapping its wings through the air. Quetzalcoatlus and other asdarchids have hind limb proportions more similar to modern running mammals than to their smaller pterosaur cousins, implying they were uniquely suited to a terrestrial lifestyle, even though they were quadrupeds when on the ground. This has led scientists to further study the lifestyle and feeding habits of Quetzalcoatlus. It's widely accepted that this flying giant was a carnivore, although exactly what it ate has been a subject of much speculation. Douglas Lawson, the scientist who first discovered Quetzalcoatlus, suggested it scavenged on the carcasses of titanosaur sauropods, much like a marabou stork. His reasoning was that the fossil was located far from the coast, and there were no signs of large rivers or deep lakes nearby when it was alive. However, this scavenging idea was debunked in 1996. Scientists pointed out that, in contrast to the hooked beaks of specialist scavenger birds, the lower jaw of Quetzalcoatlus bent so steeply downward that even when fully closed, a space of more than 5 centimeters remained between it and the upper jaw. They proposed that Quetzalcoatlus ate like modern skimmers, cleaving the waves with its beak and grabbing fish mid-air thanks to its long neck vertebrae and toothless jaws. Quetzalcoatlus most likely lived in a variety of settings during the late Cretaceous period, including coastal regions and inland plains. These enormous landscapes supported a wide array of life, and Quetzalcoatlus, it seems, was perfectly adapted to thrive in them. The thought of encountering Quetzalcoatlus. It makes me grateful to live in a time beyond its reign. Imagine a world where colossal creatures like Quetzalcoatlus roamed freely. Based on fossil evidence, we believe Quetzalcoatlus lawsoni may have lived in swarms around alkaline lakes. We think they were social, waiting birds. Quetzalcoatlus northropi, on the other hand, was most likely a solitary hunter, living inland, and it wasn't the only giant of its time. Fossils hint at the possibility that creatures similar to Tyrannosaurus and Torosaurus coexisted with Quetzalcoatlus, though conclusive studies are still needed. Alongside the iconic Alamosaurus, Quetzalcoatlus may have crossed paths with other herbivorous giants and fearless predators, such as the mighty T-Rex, Dromaeosaurus, Triceratops, Albertosaurus, Edmontosaurus, and Dakotaraptor. In the skies, Quetzalcoatlus likely shared its space with other pterosaurs, such as Pteranodon and Nyctosaurus, coexisting within those extinct ecosystems. The environment offered Quetzalcoatlus diverse options for hunting, nesting, and roosting.